Welcome all. Myself Shamla Devi, working as an assistant professor in the Department of Electronics and Communication Engineering at K.S.Rangasamy College of Technology. Today I am going to take about the concept on double sideband suppressed carrier DSB-SC and single sideband suppressed carrier SSB-SC in analog modulation techniques. In an amplitude modulation system, the transmitted signal consists of three components, which is a carrier wave, an upper sideband, and a lower sideband. The carrier is a high frequency signal used only for transmission purposes, while the sidebands contain the actual information of the message signal. So both upper and lower sidebands carry identical information. So a major drawback of conventional AM system is that most of the transmitted power is wasted on the carrier, which carries no information. So nearly two-thirds of the total transmitted power is consumed by the carrier alone. So this results in a very poor power efficiency. So transmitting two identical sidebands leads to unnecessary bandwidth usage. So these limitations makes AM unsuitable for long distance transmission and power constrained communication systems. So hence there is a strong need for improved modulation techniques which eliminates redundancy and make better use of available bandwidth and power. So since the carrier doesn't carry any information, so transmitting it is inefficient. So transmitting both sidebands is redundant, making it because they carry the same message. By suppressing the carrier and removing one sideband, we can improve system efficiency. So these concepts lead to the development of suppressed carrier modulation techniques like DSB-SC and SSB-SC, which is double sideband suppressed carrier and single sideband suppressed carrier, which are widely used in modern communication systems. First, we will see double sideband suppressed carrier. So, double sideband suppressed carrier modulation is a modified form of amplitude modulation technique in which the carrier is completely suppressed, which is the only the upper and lower sidebands are transmitted. Since both sidebands contain information, so this DSB-SC technique ensures that all the transmitted power is utilized effectively for information transmission. So this improves power efficiency compared to conventional AM systems. DSB-SC modulation is generated using a balanced modulator. So in this process, the message signal is multiplied directly with the carrier signal. So due to this symmetry of the balanced modulator, the carrier component is completely cancelled here, leaving only the two sidebands, which is the upper and lower sidebands. So this multiplication process ensures that no carrier power is transmitted, making DSB-SC more efficient than conventional AM systems. So here is the double sideband suppressed carrier. Here carrier is completely suppressed, only the lower sideband and upper sideband are transmitted, which is of frequency FC minus FM of lower sidebands and FC plus FM of upper sideband signals. So the spectrum of a DSB-SC signal consists of two sidebands symmetrically located around the carrier frequency. So even though the carrier is absent, that is carrier is suppressed, the total bandwidth needed is still twice of the message bandwidth. So therefore DSB-SC improves power efficiency, but it doesn't offer any bandwidth savings when compared to conventional AM systems. So next one is the single sideband suppressed carrier. So single sideband suppressed carrier modulation is the most efficient form of amplitude modulation technique. So in this technique, both the carrier and one of the sidebands are completely eliminated when compared to DSB-SC. So here only one sideband, either upper or lower sideband, is transmitted. Here only one sideband is sufficient to convey the entire information, and hence SSB-SC achieves maximum power and bandwidth efficiency. So SSB-SE signals can be generated using two common methods, the filter method and the phase shift method. So when we take the filter method, a DSB-SE signal is first generated and then one sideband signal is removed using a sharp bandpass filter. So but in the phase shift method, the message signal is of phase shifted and combined with the carrier so that one sideband is cancelled here. So here is the SSB SE signal. Here carrier and lower or upper sideband is suppressed here and only one sideband, which is of frequency either FC minus FM or FC plus FM is transmitted. So the spectrum of an SSB SE signal contains only one sideband. So this reduces the bandwidth requirement to that of half of the DSB SE signal. Since no power is wasted on the carrier or a redundant sideband, all the transmitted power contributes directly to information transmission. So this makes SSB SE signal more suitable for long distance and power limited communication systems. So the challenges faced in SSB SE is that even though its advantages, SSB SE has certain challenges. It requires highly stable oscillators for frequency and phase synchronization. The generation and detection circuits are more complex when compared to DSB SE. Also, coherent detection technique is mandatory at the receiver side, which increases its system complexity and also its cost. So, what are all the comparison of DSB SE and SSB SE is that uh, compared to DSB SE, SSB SE uses half the bandwidth and offers better power efficiency. DSB-SE is simpler to generate and demodulate, while DSB-SE is suitable for moderate distance communications. SSB-SE is preferred for long distance communication, HF radio, and bandwidth limited applications. So, on the whole, when we see the applications of DSB-SE and SSB-SE, DSB-SE system is commonly used in modulators and mixers within communication systems. SSB-SE is widely used in HF radio communication system, marine communication system, and military systems due to its superior efficiency and long-range capability systems. So, DSB on the whole, DSP, SE and SSB SE modulation techniques as efficient alternatives when compared to conventional AM systems. DSB SE improves power efficiency by completely suppressing the carrier while transmitting both sidebands which carries the information. But SSB SE further enhances efficiency by transmitting only one sideband and suppressing both the carrier and the redundant sideband, also reducing bandwidth and power requirements. Even though SSB-SE involves higher implementation complexity and requires precise frequency and phase synchronization, so this is widely preferred for long distance and bandwidth limited communication systems. Overall, both DSB-SE and SSB-SE play an important role in modern analog communication systems, which enables efficient, reliable, and economical transmission of information. So these are all the questions. So try to answer these questions by uh, listening to the content which I explained here. So try to answer these questions. Which one is the power efficient and all? Thank you all.